Well, hi everyone. Today looking at two chapters, chapter 10, an introduction to statistics, and then chapter 11, visual presentation of data. So let's hop straight into it and see what we can do together. Here we go. So chapter 10, intro to stats. A quick tip. Here we are, week 5, and probably not a bad time if you're not already doing this. It's a great thing to obviously look at this recording before class, but also having a flick through the chapter will give you, make life easier. I've said most likely improve your chances of passing, and certainly what we do in class will make a lot more sense. So why? I mean, you've probably spotted already why the importance of statistical data, particularly with COVID-19, and just, trying to decide how we're going, what do we need to do, measuring risk. Investors are looking at statistics all the time, trying to work out which products they should be looking at. But here's some of the issues where we might be using it. We might be looking at the economy as a whole. We're gathering data, working out what new opportunities there might be for supermarkets in a particular suburb. Do we need a new hospital here? What's the population growth looking like? What about a new school? How are our roads going? So really predicting and planning for the future, statistics plays a huge role in making that happen. Statistics also involved in quality control. Clearly, imagine we're producing Samsung phones, and we're going to put it through their paces. We're going to drop this phone from a 3-story building and do a whole lot of other things and test its, durability and performance and whatever. Now, clearly, if we test every product, we want to get some sort of certainty as to how good our product is. So we're going to obviously do a sample. If we test all of our product, we'll have nothing to sell because it'll all be busted. So yeah, statistics in investments. We'll look at some point about how you could use the Australian Bureau of Statistics, Yahoo Finance, the Australian Stock Exchange website, the asx.com.au, all sorts of, and at some point during the semester, you'll most likely be going to the Australian Bureau of Statistics, gathering some data or using some data to solve some problems from what we're doing in class, and coming up with hopefully some good practical answers. And that's really what it's all about, gathering data so we can help make some good decisions into the future. It's too late to wait 5 years. You've really got to start building dams, 5 or 10 years before you really need them, and planning finances and doing all of that sort of thing. So that's what we're on about. Here's imagine you're designing a survey question. I've got a hypothetical question for you to think about. Is it better to get the right answer to the wrong question, or get the wrong answer to the right question? Now, you might want to pause the video for a moment and think it through. Have a guess. 50-50 chance of getting this one right. Do you want the right answer to the wrong question, or do you want the wrong answer to the right question? Well, if you think about it, once you get an example like this, let's walk through an example, and then it'll be very clear as to what the right answer is. Imagine you're a politician trying to work out what your chances are of winning the next election. And so you go to the people, and your question is, who did you vote for in the last election? And you collect all the data perfectly, it's recorded correctly, but unfortunately, it's the wrong question. You need to be thinking, your question needs to be, who are you planning to vote for in the next election? So that's the valid question. So imagine you did ask the valid question. So what we're trying to prove here is, wrong question, no matter how accurate your answers are, it's going to lead you astray. Whereas at least, imagine you ask the right question here. Who do you intend to vote for in the upcoming election? And imagine you make a few mistakes. 5% of the responses were maybe recorded incorrectly, and a few people gave you some wrong answers. But at least you're 95% sure of what the outcome might be. Here, you might be, way off the mark by the time people have moved on, changed their minds and all that sort of stuff. So hopefully that is helping you. It's a very, very important thing. The point we're trying to make is that you want to make sure your survey questions are clear and are solving and gathering the data that you are really looking for. So we're going to look at what's the difference, and that some of these these could crop up in a theory question, a multiple choice question at some point. And so what we're seeing is that the population is all the data that you happen to be studying. Now, interestingly enough, when you think population, you think, oh, it has to be big, it has to be all encompassing. But no, it's just what you're trying to gather. So if you were wanting to gather the number of cars that passed a certain spot at 8 o'clock on a Monday morning, between 8 and 9 on a Monday morning, and you stayed there from 8 till 9 and gathered all the data, you are dealing, that is your population. You've gathered all the data. It's only if you chose to say, oh, look, I won't stay for the whole hour, I'll just stay for 15 minutes, I'll gather data for 15 minutes, that's my sample, and then I'll try and make an estimate of what the rest of based on the first 15 minutes, let's extrapolate that out and try and estimate what we think the next hour might be for the rest of the population. So a census is the process of gathering all the data, making sure we've covered everything, whereas a sample subset. So it's three key terms here. Know what a population is, know what a census is, and know what a sample is. So what's the difference between a parameter and a statistic? Well, a parameter is when we try and do a calculation. Descriptive measure simply means we're describing what's going on in the population. So we're doing some calculations on the population. So anything we do with population data, that's what we call a parameter. A statistic is any sort of calculation or measure that we might be conducting on a sample. So interestingly, so we've got statistic, the topic, and statistic, the measure, if you like. So two meanings of the same word. Notice too that a population, you can always pick it up. If you see this Greek letter sigma in any of the notation, in any of the formulas, on your exam sheet, formulas, textbook, whatever, that it means the population standard deviation. If you see this mu, Greek letter, it's the population mean. Whereas if you see Roman letters, little s for standard deviation, a helpful way of remembering that is sample is smaller than the population. So S for sample, S for standard deviation of the sample, maybe that helps. And X should have a little bar above it, X with a little bar for the mean of the sample. So we've talked about that. Interestingly enough, the population standard deviation squared is the variance, or square root of the variance finds the population standard deviation. And in a few weeks' time, we'll be doing some calculations where you can actually see how we calculate these. This is essentially the deviation from the mean. And here we are with our sample statistic symbols. And let's have a look. If you're using the financial calculator in the next few weeks, we'll be going mode 1, 0 to switch it into statistical mode. And you'll see these, if you're running with two sets of data, mode 1, 1 for a line, two sets of data, you would be entering, when you enter the X data, you'll be hitting the XY button. And when you're hitting the second series of data, you'll be entering the Enter button. So more practice of that when we get down the track. But what that means is once you've got all the data in, you can go recall for, and you'll get the mean of the first set of data that you've entered. When you go recall 5, you'll get the sample. If it was a sample, you got to make sure before you do that. And if the question said, hey, what's the standard deviation? You've got to work out, now, am I dealing with all of the data or a sample? If it was a sample, recall 5 is the right answer to give you the sample standard deviation. Just when we get to look at the formulas, you see there's a difference. One divides by n, the other divides by n minus 1. Population minus 1, or population size or sample size. And here, that little sigma tells me it's the recall 6 is going to give me the population standard deviation. If I want the second set of data, recall 7 will give me the mean of the second set of data, recall 8 will give me the sample standard deviation of the second set of data, and recall 9 will give me the population standard deviation. So a few little buttons there to push on the calculator. We can solve these questions also using Excel. We'll do both in class. So what is it? We gather the data. Really, you know, if I was to walk into a meeting, you know, the directors are there, and I gather the data, and I just drop a box of data with the raw forms on the table, you know, it's not going to mean anything. We need to gather it into some sort of semblance of order, make some summaries there so we can, you know, cut to the chase. We really need to gather it and present it in such a way that it can be understood. So that's what we're really on about in our subject. And a couple of other bits of terms that we've got to get our heads around. One is descriptive statistics. Simply gather the data, display it, record what has happened. Descriptive, describing, if you like, is the root word, describing what's happened. A statistical inference is when we use the gathered data to make predictions either about the future or about the rest of the population. So every time we gather data about the sample and then try and predict what the rest of the population might be, that's inferential statistics or a statistical inference. We draw a conclusion based on past data as to where we might be going in the future. So how are we going to do it? Some data is measured and some data is counted. So whenever you can ask the question, how many, then that's obviously counting. How long, you know, weights, heights, etc., data that can be measured. More of that in a moment. Sometimes we might want to rank data, particularly when it comes to customer service things. We would definitely want to deal with the most pressing problems first and get them sorted. So some good reasons that we might be interested in ranking data from importance, in level of importance. So we might just want to break our data into different classifications and categories to make sense of it. And we're going to deal with 2 different ways of analysing or thinking of data. We've got quantitative data when it's a numerical quantity that can be counted or measured, and qualitative when it's a non-numerical description, you know, something like the colour, anything that's describing the quality of a product. Then we're making a judgment perhaps, or we're looking at its particular qualities. We'll look at that more in a moment. Primary data that we are involved ourselves in gathering the data. We're the ones who gathered it. Secondary data is when we rely on somebody else has gathered the data on our behalf. Maybe we've gone to the internet to find some information, the Australian Bureau of Statistics, etc. It's a 6-minute video, and if you wanted to pause at some point, you needed to take a little break, I think you'd find that fascinating. Did you know? If you go to that YouTube clip there, fascinating and sort of entertaining. What they're doing in this video is that they are using historical data, past data, or data right up until today, to predict what our world might look like. So lots of inferential statistics going on in this video. I think you'll find it helpful. 6 minutes, pretty relaxing, pretty easy to watch. My only hint or piece of advice, maybe you might want to turn the speakers down. I found the soundtrack a little bit annoying. So you might also might be interested in, our media here in Australia reports daily on what's going on in the coronavirus, but really they're only looking at Australia. And you might say, but how's the rest of the world going? Where do we fit with the rest of the world? So you could click onto that site there, and it will take you through. You can click on country by country and go down. I think we're about 69th ranked in the world in terms of total number of cases. And of course, there is some data in here that you would question the validity of it, as how accurate the data has been collected. So we're relying on, different countries to be upfront with what's going on. So some of this data might be, a little less accurate than others. Won't point out any particular countries. There's plenty more. There's hundreds down on the list. And there's one particular country that is a long way down the list that causes me to doubt whether it really belongs there and whether it shouldn't be further up on the list. I'm not going to say any more. You can draw your own conclusions about that. So yeah, lots of things, deaths per 1 million population. So it's handy. It's one thing to have the raw statistics. Always good to look at it in terms of the total population. So, India, for the size of their population, is doing better. Obviously, it's, well, even in raw terms, doing better than the US and Brazil. Look at Brazil here. You'd be worried. In Brazil right now with those sorts of figures based on that population. Here's the graph. You keep hearing about flattening the curve. Worldwide, we haven't turned the corner yet. Both graphs, unfortunately, are still going up. The beauty of a graph, later on in the second half of today, we'll be seeing how, again, a picture paints 1,000 words, and visually, it's one thing to look at a whole lot of data like that, but your mind can cope with trends a lot better when you see it in a pictorial form. So speaking of pictorial forms, we might just go live on this for a minute and just see. It's quite a good presentation. I'm going to see if I can find it. So if you went to this website here where we're going live, and quite good when you're looking at visual presentation of data and information, we've got time down on this axis here through to today, 2020. And we could see, we'll just pick out a couple of pieces of data here. In 541 to 542 AD, 30 to 50 million people, a third of the world's population, wiped out by this particular plague. The bubonic plague in the 1347 to 1351, massive, 200 million people. I think we'll go and have a look at that in proportion to the population at that time in the 1300s. Smallpox, 56 million in 1520, but it was only recently wiped out. It was still killing millions of people through the 17th, 18th, and it's only in the last 80 years, maybe 1960 or so, that the last case was sort of eradicated through vaccines. So all the plagues, HIV, AIDS, Asian flu, Hong Kong flu, swine flu, SARS, Ebola, and COVID ongoing as at the 10th of August 2020. So fairly up-to-date graph, fairly helpful in terms of, giving us a picture of what's going on. So quite well done. You can see the value of information like this. It's much more your mind can absorb it so much more than if we just had data on a page. It brings it to life. So that's what we hope to do today, is do a little bit of bringing statistics to life for you. And yeah, so here it's one thing to have the data, but then to try and put it in perspective. So this 30 to 50 million was half of the world. Imagine half of the world's population wiped out between this period, and a third of the world's population wiped out. And then the Spanish flu, 5%. So, you know, big figures, and then we put it in perspective and we get a sense of what the picture really looks like. So here's some of the secondary data available on the Australian Bureau of Statistics. So from things like alcohol consumption to the number of building approvals to crime rates to unemployment rates, our gross domestic product, household expenditure broken down, average weekly income. So all inflation, consumer price index, a wealth of data gathered every 4 years. I mean, some of it is coming from other sources from each year. You know, companies are lodging their reports. Tax offices got gathering a whole lot of financial information. But every 4 years, we've got the census happening, gathering all the data on our population. An expensive operation to gather this data. But it's important. It's important for governments in planning for the future, for businesses planning for to meet the needs of the community. Let's have a look at different types of data. So we could break data down into qualitative / categorical data and quantitative data / numerical. So let's run with the quantitative. Quantitative is, it could be discrete or continuous. So there's a little bit of breakdown of data. We've got quantitative discrete data, quantitative continuous. And there'll be a couple of questions that will get you used to analysing and categorising data. Discrete, whenever you can ask the question, how many, then you've got discrete data. So how many times do you go to the shops per week? It will be 2 or 3. It won't be 2.5. You can't go to the shops 2.5 times a week. Or how many children do you have? You know, yes, when you do an average, you might average out over the population of 3.25 children per household. But essentially, what we're trying to say here is we get a continuous data. It's measured time, weight, money. It's on a scale. And we have to work out, well, we break that scale down. Anyway, when you'll see when we gather the data that we have to arbitrarily decide, do we, like money, for example, do we go to the nearest $500, the nearest $100, the nearest $1,000? What are we trying to measure as we present this data? Qualitative data could be nominal or ordinal. So if it's nominal, like a category or color of a car, so we might give it a number. We might, but the number means nothing. It's a category, it's a code. You can't add it up. I'll give you an example on the next slide of that happening. But if it's something like a test grade, it is qualitative. We're talking about the quality of the result, but you can do something with that. You can rank test grades, so it does have an order to it. So this is what we were talking about before, that we've got qualitative data and we've got numbers to identify. We've just made up these categories, 1 for teacher, 2 for construction, etc. And so you don't add it or anything like that. It's a category. It's a label, so to speak. From that, even though it's qualitative data, so it's not numerical, you could still do numerical calculations on that qualitative data. You could say, well, of all of the professions, what percentage of people in this particular suburb are teachers? You know, so we're doing some numerical calculations, you know, on our qualitative data. And here, again, we're ranking. People are making a judgment on the level, on the quality of their service, perhaps, that they've received. And so it's still qualitative data, but you can rank it, and you could also say what percentage found the service very helpful. 20% of people found that the service very helpful, whatever. So So yeah, hopefully you're getting a sense of statisticians like to categorize things. It's important for us to be able to understand that. So again, qualitative data. And so let's have a think about it. It's about the perceptions of people, their opinions, what they feel, and they're making a judgment. Quantitative data is where we would then gather that data and perhaps rank it. So I've just said here we gather qualitative data, but it becomes quantitative data when we measure it and ask, how many, 80% of the people. Okay, so we've covered that. One last example. So if I asked you what color your eyes are, this is a quality about you, and it's qualitative data. And it's your opinion. I can't measure the color blue. I might think your eyes are grey, but you're giving me your opinion that they're blue. But if I ask you how tall you are, it is also a quality that you possess, but it's quantitative data because I can measure your height, and to obtain the information, I don't have to rely on your opinion there. What can go wrong as we gather data? Just a couple of examples. It looked like this cost billions of dollars, and 7 of the crew members died when a Space Shuttle Challenger exploded. Tragic event, and it possibly could have been avoided. There was this little O-ring was becoming, some data was left out of the analysis, and possibly had it not been, they would have realized that there was a failure of this particular component part. This component part might have only been $20 or something like that. And had they replaced, they would have realized, no, we've got to replace these O-rings more, frequently or whatever, or the temperatures have to be right. If they're not, we've got to replace them. So it had something to do with cold temperatures were, so just really interesting from an engineering perspective, it's important. The failure to gather the data and report it can have huge ramifications. This was a case of a solicitor, and who was, we believe, wrongly convicted. It was very sad, very tragic. She lost both of her boys at this age, and when it went to court, they said, and unfortunately, it cost her life. It ruined her. But she was accused. They said, statistically, that's impossible. She must be guilty. And later on, a professor came out, and his comment was, no, statistically, they got it wrong. It is possible. It's unlikely, but it is possible that she was innocent. And so really, gathering the data and making sure that data is right and not misinterpreting the data, very important part of statistics. So let's have a look at the visual presentation, chapter 11 of data. We'll walk through a few different styles of graphs. First way you might want to present data is in a table. So we can break data down. We've got age groups here. We've got different codes of sport, and we can gather it. And from here, we can do a whole lot of analysis, percentages, and work out, where the trends are. We can have raw data. So we're going to look through ungrouped data, and then we're going to try and group it to summarize it and work out how we do that. So let's have a look. Here's the raw data. And this is what I was talking about before, these are the monthly unemployment rates for 50 months gathered from July 2004 to August 2008. 50 pieces of data. It's hard for your mind to just, it's all over the place. It's a bit ugly. So we need to make some sense of that. Let's put it into some sort of logical format. So one of the ways we might do that is break it into groups. And so we've decided we're going to work out how we worked out those groups in a minute. But the way this works, we can then go, all right, let's break it into categories. And an interesting notation, when you see the little interval, class interval here with a square bracket, because the question might be, what do I do if I get a 4? Does a 4 belong in this category, or does it belong in this category? And so that one helpful way of remembering that is that when you see the little square bracket, think of it looks like an I for include. That helps us know that, look, it helps me remember that a 4 would be 3.75 up to 4 would be in this group. If there was an only 4.01, etc., would be in this group up to 4.25. And as we gather the data, we're just counting it, basically. If I was doing it manually, I'd start in the first group and I'd just, if you had to, I had pieces of data on a page and just cross them off as you entered the data into the different categories and add it all up, and hopefully it came to 50 at the end. Otherwise, you'd know you're missing some data. But already it starts to give us a bit of a sense of where the data is looking, where the majority of the data is lying. We're getting a bit of a feel for what's going on. So how might we come up with the group? Well, the first thing we might do is find the range. Grab the largest figure and the smallest figure and find the range, 1.7. And then we might decide, well, how many classes do we want? How many groups, intervals do we want? If you have less than 5, you're summarizing too much. More than 15, and it's getting a bit cumbersome. So let's imagine we've decided we want 8 groups of data. So we found the range from the highest minus the lowest piece of data was 1.7, divide by 8, and we get this figure here. And then with 0.21, we might say, okay, well, let's round it up to 0.25 and start from our very smallest piece of data. Let's start building it from there. So we might start, look at the data, the raw pieces of data. I'm just going to go back and find what our smallest piece was, 3.9, say, okay, what's close to that? Let's go back to 3.75 and start our first group at 3.75. So we do that, 3.75, and add, just going to go back, add 0.25. So my first group, 3.75 to 4, and to find the midpoint, divide by 2. You might say, why are we interested in finding the midpoint? Well, we'll show you on the next page. Maybe not the next page, but next slide in a couple of minutes. This slide is showing us the relative frequency. All we're doing there is showing the frequency in a particular group as a percentage of the whole. So 1 over 50 is 0.02. 5 over 50 is 10% or 0.1. If we add all that up, it should always add to 1 if we've done all those calculations correctly. Cumulative frequency is important, particularly later on. You'll see an ogive when we need the cumulative frequency to make that happen. So the frequency in this group was 1, and then all we do is grab that frequency and add the next frequency and say the cumulative frequency so far between that group and that group adds up to 6. 6 and 16 is 22, and 4 is 26, and 10 is 36 plus 11. We keep going all the way through. Again, if we've done it correctly, it should come to 50, the total. We'll see that the importance of that when we see the ogive. Now back to the midpoints. Why are they important? Well, the mathematicians go, if we want to calculate averages and standard deviations and all of that, and we've got this grouped data, say we look at this particular category here, or interval, and there were 16 that were in the range of 4.25% unemployment and 4.5% unemployment, but where was the real data anyway? How many were down this end and how many were up this end, and what's the spread? And the mathematicians go, look, to be fair, let's just use the midpoint. It's a bit of an estimate, bit of an average. Yes, it won't be exactly accurate, but it's close enough. So we'll find the midpoint of each of these class intervals, and that will be good enough for us to do our calculations. Quick slide here, bit of a case study from a presentation I went to, and you've heard the saying, perhaps, statistics don't lie, but statisticians do. And I happened to be at this presentation from there was a salesperson up the front, and you probably have come across salespeople, real estate agents perhaps, or car salesmen who have a habit of just maybe presenting an optimistic view of the world. You know, I'm going to be kind. I'm going to say it's not deceptive. But And he said in his presentation, he said, our goal, and so this company had been operating for 30 years. And he said, our goal is to have 2 billion users by 2021. And a lot of people, and then he goes on, a lot of people, and I thought, hang on, well, that's okay. That's well and good, but I wonder how many you've got now. So he talked for a little bit longer, and I asked, how many users do you currently have? And he said, oh, yeah, we've got 900,000 users. And so I'm thinking, well, it's taken you 30 years. So he didn't lie when he said our goal is to have 2 billion users by 2021. It's a lovely goal, but is it realistic? And here it's taken 30 years to get 900,000 members or customers, if you like, and they hope to get 1.1 billion. They hope to double it in the next 12 months. Somewhat optimistic. This company wasn't Facebook, but so it's just interesting sometimes to just dig a little deeper when people start throwing statistics around. Just question it a little bit and say, what does this look like? Am I being taken for a bit of a ride here? Well, let's have a look at what are some good graphs, what's important. So a textbook outlines some pretty common sense sort of things, what we should be aiming for in presenting a good graph. We'll have a look at it in detail. One graph is a histogram, looks like a bar chart. Essentially it is, and Excel can draw a nice little bar chart for you, and you can actually eliminate the gaps between the bars. You click on the spreadsheet, we'll do it in class, and you end up with a histogram with all of the bars joined together. Notice they've put not the midpoint in the middle of the interval, but the end point of the interval that they've actually put as the middle of the bar. It's an interesting way of displaying their histogram, but it's label, unemployment rates, and frequency, the number. So it's fairly clear. What about a frequency polygon? Very similar. Polygon means a many-sided shape. And so technically it should come down to the x-axis and complete the shape, close it in. But essentially all it is the histogram, but joining the midpoints of the histogram. So I'm going to draw a polygon on top of this. It's going to go, oops, I've lost my mouse. Here we go. Up to the middle, down, up, etc. And so we end up with a frequency polygon that looks like that, just joining up the midpoints of the various bars. An ogive, here it is, using the cumulative frequency, and we can see the unemployment rates going through. Now, with the graphing the cumulative frequency remember numbers frequency up here and the rates here, the advantage of the ogive, best way to interpret the ogive, a lot of people are looking, well, where's the top 10% or 90% of the months? What was the unemployment rate? And so, for example, here we might say, look, I've got 50 months all up. What about half the time? Half the time's 25. So you might read off here at 25 and go, okay, look, half the time unemployment rates were greater than 4.75, and half the time they were, between 4 and 4.75. So it just gives us a way of, working out percentages with the data that we're looking at. Pie chart, it's probably produced a few pie charts in your time. Very good for showing the breakup of data. This is a nice one. It's all labeled. Excel's doing a good job. A nice thing with Excel, you can click on the values, and you can even rotate if you didn't like the fact the way the pie is located. It enables you to rotate it. We'll do that in class, and you can get it looking pretty good. Again, often if you think of a company with operating expenses, you might want to break down your expenses into different categories and what percentage of your operating expenses were wages, say, etc. So another good use of the pie chart. A stem and leaf plot. Well, better to actually look at the data. Sorry about the colors here. I couldn't change it. Actually was a picture that I've inserted. So We'll run with this terrible red color for a minute. But the way it works, if I go looking for the data, and it looks like there must be, this is telling me there must be 23 in here. Somewhere in here is the number, there it is, 23. So I tick it off, I go, okay, 23. The stem is the 2, the 20, and the 3 is the leaf. So this data has also got a 39 in there somewhere, just one item of 39. There it is, 39. But there must be 47 and 49, two lots of 40s. There's the 47, and there is the 49. So we tick that off, tick that off. We've completed that part of the plot. So the advantage of breaking the data into this like a stem and leaf plot, it starts to create a little bit of a picture. We can see that most of the data is gathered around the 60s and the 70s and the 80s. Starts to create like almost like a frequency distribution on the side. Done it. Pareto charts. Helpful for when you've got this qualitative data, such as people reporting on what were some of the issues, the defects in a particular service, and what by putting the largest item first, we can find what the biggest problem was, and maybe we're interested in dealing with the biggest problem first and then moving on to the rest of the problems. So a nice way of, just presenting data, or a good reason for presenting data in this format, Pareto chart. And again, Excel, you just sort the data from highest to lowest and then graph it, and you'll get a Pareto chart. We'll do a little bit of that in class as well. Scatter plot, helpful for seeing, is there a relationship between my x-axis, residential sales maybe, or construction, versus non-residential construction in dollars? And it seems there is some link. It's a bit all over the place. The dots are a little bit over the place. So there is a little bit of an upward trend. The more money that is spent in residential seems to be the more money that's spent in non-residential, but it's the closer all those dots are to a line, the closer the relationship between the two, or the correlation between the two items seems to be. We will look at correlation in a few weeks' time. Misleading bar charts. This is the same data as this. And the reason is that this scale doesn't go to 0, it only goes to 7. We're really only seeing the top half of this graph. So it makes Telstra look amazing, but when you take it back to 0, yeah, they're still better. I'm not saying that this is current information, by the way, it's probably moved on since then, but they're better, but certainly not like that. Again, the scale is important. This is the same data. So when you go to 0, we get this flat curve. And there are times when you might say, yes, but I'm losing. I want a sense. I want to get a sense of the volatility. So it might be a valid time to say, no, it's okay not to go to 0. Let's just look at the volatility in the last few months between a certain range. And I get a little bit more data. We're losing data up here. We're not seeing the full effect. This gives us a better view of what's going on. I'm going to suggest this is a reasonable, well, I'm going to say it's a good graph. Let's see why it's a good graph. We've got inflation rate for the last 63 years in Australia from 1965. We can have a look at how it's going over in the long term. But what's sort of nice about it is it's reasonably clear, and I like these grids along here. We've got a little bit more data as to what might be going on in the economy, but these lines here help us read off. Without those lines, it's a bit hard to sort of pick, where the graph is up to. So these segments, these colors are helpful for getting your mind to draw in and know that it's in this range. Where were we sitting in this top range? And just helpful for, color is nice, but it also helps us interpret the data as well. Bad graph. pretty clear that it's a mess. And where did it come from? Anyway, yeah, the Canadian Real Estate Association. Wow, how do you read that? It's just it's spaghetti. It's hey, the graphs are labeled, but I don't like it. This is a really early Excel graph. In the early days, you could produce things like this, and it looks really amazing, doesn't it? It's really hard to read. We saw those earlier, that play graph we were looking at a little while back. That was helpful. And this is not bad either for showing population. The higher the spike, we can see the density of the population then. And as we get out into the country where it's spread out a little bit more. So, I thought that's not a bad way of visualizing population. We're going to finish on the last few graphs here. A bit of humor to finish the day. Thoughts when a car alarm goes off. This graph was never meant to be taken seriously. That's annoying. Let's go and deactivate it. Or red, someone's actually stealing a car. Maybe you can relate to that. When falling asleep feels the easiest, in class, at work, in bed, actually trying to sleep. Never meant to be taken seriously. Things that reportedly taste like chicken. KFC right down the bottom. Everything else is, don't know if you've had this experience, but everybody says, what does snake taste like? Oh yeah, it tastes a bit like chicken. What about emu? Oh, crocodile, definitely. Tastes a bit chickeny. Yeah. And finally, last graph. We will in class see how we can gather huge amounts of financial information from Yahoo Finance and use that to predict trends into the future. That's enough for today. Hope you found that helpful. And I'll be jumping out and seeing you very, very soon. Bye for now.